Hi guys, Mr. Gillen here, and during this video we are going to look at something called scientific notation. So, a bit of a background. Scientific notation is a way that helps us to write really big numbers, like this one, in a much shorter way. And what that does is it allows for less errors. So if you were to think about if you were asked to write that number, then it would be a very hard task to count all the zeros. And if I was then to ask you to work with that number, it would be annoying to continue to always write it out at the same all the time. So we've got to have a way that we can write really big numbers in a much shorter way. So we're going to look at what scientific notation must have before we actually look at what it looks like and how we convert it. So scientific notation must have a number between 1 and 10, so anything less than 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, to the left of its decimal. The next thing that we have is we've got in scientific notation, we've got multiplied by 10 and then to the power of the number of jumps. We're going to come back to that point. That's a very important point. And for doing scientific notation, you've got to be confident with this part. So we're going to come back in that and look at it in more detail. But keep that in mind. Multiply by 10 to the power of the number of jumps. In scientific notation, any leading or trailing zeros are lost. Okay, so we'll discuss more what that means. We're going to concentrate in this video on trailing zeros. And if there's any non-zero digits, they are still included. They don't vanish. So a good idea would be to copy this and pause the video and put it into your jotter so that you've got this information. So let's look at some examples. We've got 987,000 and we want to write 987,000 in scientific notation. So let's think about what those rules were one more time. We need a number between 1 and 10, and all other digits are included. So 9 in terms of place values has the largest place value. So we're going to have 9, and then I'm going to put a decimal. So we should always have one number to the left of the decimal, which we've got. We also said all non-zero numbers are included. So the 8 and the 7 are going to go in here. We also said that trailing zeros, we lose them. So these are trailing zeros here. So they're trailing zeros because they are coming at the end. So let's think about that rule that we talked about, or we said we would bring back up. We said multiplied by 10 to the power of the number of jumps. So this is where the scientific notation part comes in. We've got a number, we've changed it to a decimal, and we're now going to write times 10 . Where does this number of jumps come in? Well, if you think of 987,000, the decimal point would usually be here. When we've rewritten it, the decimal point is here. How has it got from here to between the 9 and the 8? It's jumped. So it's moved 1, 2, 3, 4, 5 times. So in order to complete this, we're going to have to put 9.87 times 10 to the power of 5. Let's look at 2 more examples. This time we have got a rather large number, 40,300,000. Again, if you are working in maybe science and physics and chemistry especially, where you deal with really large numbers, you don't want to be writing these huge numbers over and over again because mistakes can creep in. So we're going to need to change them to scientific notation. Again, the 4 is the biggest number. It holds the highest place value. So I'm going to put that on the left of my decimal. This 0, think back to when we did place value. This 0 has place value because there's a 3 beside it. So I need to put this 0 in. And then up here, I've got my trailing zeros, which I'm going to lose. In order to get it to scientific notation, I need to have my times 10. And I now know that I need to count the jumps. So again, I've got 1, 2, 3, 4, 5, 6, 7. So in order to change 40,300,000 into scientific notation, I have 4.03 times 10 to the power of 7. One more example we'll look at. This is a huge number we've got this time. So again, I'm not going to change my process. I'm going to take the number with the highest place value, which is the 8, and I'm going to place that on the left-hand side of the decimal. My 7 has to be kept in, and then after the 7, we have got all of these trailing zeros. So I'll lose them. I don't need to write them again. I need to change it to scientific notation. So I know that I'm going to do times 10. I need a power in there. I need to know what my jumps are going to be. So after the 8, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in order to change this number into scientific notation, I need to do 8.7 times 10 to the power of 12. What happens if we want to reverse it? So this time somebody has given me scientific notation and I want to change it to number form. Well, I know that this 9 is going to hold the highest place value when it's in normal form. So I'm going to write the 9 out first. And then I know that my 7 is my number of jumps. So what I can do to make it easy for myself is I can draw in those jumps or those spaces where I know I'm going to have to fill. Now, beside the 9 in the original question, there's a 5. So when I write my answer, I'm going to put the 5 beside it. And then to fill these spaces up, I'm going to bring back in my trailing zeros. So 9.5 times 10 to the power of 7 is 95 million. If we look at 1.23 times 10 to the power of 6, again, I know that 1 has the highest place value, so I'm going to write the 1 first. I've got power of 6 this time, so that is going to be the number of jumps that I have. And I'm going to draw those jumps in before I do anything. I'm then going to go back to my original number. Beside my 1, I've got a 2 and a 3. So in my answer, I'm going to write a 2 and a 3. And then the remaining spaces, I'm going to fill out with zeros. I'll do 2 more examples for you before we finish, just to give you an idea of how you would set it out in your jotter. So we've got convert 208,000 to scientific notation. So the first thing that I'm going to do is I'm going to write out the number again, 208,000. The 2 has the highest place value, so I'm going to put that to the left-hand side of a decimal point. And then I'm going to add in any other numbers that have place value. So the 0 and the 8 do, so I'm going to put the 0 and the 8 in here. These 3 are trailing zeros, so I don't need to include them. And now I need times 10. How do I get the jumps, or how would you work out the jumps? Well, the easiest way to do it is to count 1, 2, 3, 4, 5, the amount of numbers after your first one. So we've got 2.08 times 10 to the power of 5. To convert back the way, how would you work it out in your jotter? Well, we've got 1.55 times 10 to the power of 4, and we want to put it into what we call standard form, numbers. So again, the first thing I'm going to write out is the 1. It's on the left of the decimal, so I'm going to write the 1 first. This time I'm going to look at the power. It's to the power of 4, 10 to the 4, so I'm going to have 4 gaps. And then any numbers that follow my decimal are going to go in first. And after that, if there's any more gaps, it's going to be trailing zeros. Write it out again so it's a bit neater. So 1.55 times 10 to the power of 4 is 15,500. Thanks very much for watching. If you need any help, as always, don't hesitate to get in contact with me. This is Mr. Gillen signing off. Speak to you all soon.